Hello everybody, this is Shaheen. So today I am going to solve the another problem from top interview questions. The second one actually I have solved previous first one in my previous video. So I've said about it why I started this. You can see the first problem and I explain myself why I started this here. So today let's start second one, which is maximum depth of binary tree. This problem. So in this problem, the statement given a binary tree, find its maximum depth. So we have given a binary tree. We know about binary tree. In a binary tree, uh, a node can have at most two child. A parent node. Yeah, this is if this is a binary tree. So this is a node. These are all are nodes. So in each node like 20 have two leaf node or child node. Here child node 15 and 7. So at most, that means the condition is pretty basic. There is a node can have at most two children. So this is the condition of binary tree. So what we need to do, we have given a binary tree and we need to find the maximum depth of it. So what is the maximum depth? Maximum depth is from root node. If we start traversing from root node to any leaf node, the distance between them, that means how many edges we need to pass to go from root node to any leaf node. Like this is a leaf node. A leaf node is that node which have no children, so child. So here 9 is leaf node, 15 leaf node, 7 is leaf node. So if we consider this is a root, so from 3, that means root to go to 9, we need to pass only one edge, 3 to 9 edge. So this is this depth is 1. Then if we consider 15, then we need to pass 2 edge. If we consider 7, we also need to pass 2 edge. So its depth is 2, but just its number of edges we need to pass is 2, so the depth is actually 3, like, because level, we we just here use leveling. So if we use this like 0, then 1, 2, there's a leveling. So this is the problem statement. This is depth 3. Why depth 3? Let's explain. The maximum depth is here. The definition is here. The maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. Okay, so here they explain the definition of maximum depth, like the number of node we need to. I said about that number of edges. How many edges? So if we need to pass 3 unique edges, then is like here 2 unique edges. That means we are connected these two edges with 2 plus 1 nodes, like, yeah, because 2 nodes is connected by 1 edge, that's why. So I hope you got it. So that means the depth will be number of edges plus 1. Okay, so how can we approach it? A leaf is a node with no children. Yeah, leaf, they explain the definition of leaf. So how can we approach this problem? It is we can do it like, think it like recursion. Okay, fine. We will thought about it recursion later. Let's understand it. Like, let's see, we have only one node, which is root node. So what will be the depth? Depth will be 0. But what will be the number of edges we need to pass to go to root node to leaf? So root node, if root node has no children, that means it is also leaf node. So then we need to pass 0 number of edges to, because to go from 3 to 3, we don't need to pass any edge. So at that case, what is the number of what is the maximum depth? There is number of edge plus 1, that means 1. So if we consider root node has two leaf nodes, one is, as it is binary tree, one is left part, another is right part. So we can think it like, let's say we don't have this one. When we come here, we don't have any further above thing and also left part. We only consider this part. So this is this 20 when we come here is also another root node for another subtree, like this subtree. Okay, so if we find these 9 and 20 is the children of 3, so if we know that maximum depth for this subtree and also for this subtree, if there is another children or ages there, so we what if we like we know these two subtrees maximum depth, then what we need to do to find this root subtree, that means overall full subtree maximum depth, we just need to see which one is the maximum left part depth or right part depth. Then we need to add one more thing, one, to find or to get the maximum depth for root 3. So let's understand or let's do it in code. So here in code we are given a root, it is a struct, it is a just pointer, root pointer. So let's describe a function which is our helper function. Let's call it helper function, and what we will give it root. You can I prefer to use it like this way. You can also use it like this way. So let's give a root, like we call it, if we call it with the root, any root, like at first we will call it by this, then we will call it by this left part and also right part. So at any time we are calling it with a root of a given of a subtree. So if this is the base case or condition case, if root not root, or we can write it like this way, root is equal to null, that means null we call by a null root, like when we come 9, if we call left part of 9 or right part of 9, it will be a null. That time we need to just return 0 because it is not valid. So otherwise what we can do, we can further call it in two part, like left part. For left part we can call it helper root left. For right part, that means left part means like if we are here, then left part this one and right part this one, we will find out their maximum depth. So as we have said, so now we know about this maximum depth of left part and also maximum depth of right part in these two variable. So what we will return, we will return maximum of left and right plus 1, because we need to consider this also, this one also, yeah. So here we just, what we can do, we need to just call helper function to get our answer with the root, then we need to return it to our main function. Let's run it, let's see what is happening. Yeah, it is given the perfect answer. So I hope you guys understand it. And as I said my previous problem video, that I am not teaching others, I am just trying to share my thought process. This is the purpose of this series, and I started with solving top interview questions. So I will try to go, I sorted them with the difficulty from easiest to hardest. I will try to go further serially, inshallah. Thank you everybody.